Let's talk today about one of the conic sections that you covered in Algebra 1 and Algebra 2 as well earlier in the year, and that's the parabola. But we're going to look at it a little bit differently today. So the parabola, of course, is that U-shaped curve that we saw earlier in the year, but it can also be left or right. Now, those are not functions, of course. They fail the vertical line test. But we're going to have ways to write these equations, and we have to go through a whole bunch of vocabulary first. So just bear with me as we get the vocabulary out of the way. So this point right here is called the vertex. You guys know that from earlier in the year. And there is this special point called the focus, and it's on the inside of the curve. If you think about this as being like a headlight lens, this is where the light bulb would go so that all the beams of light come out in parallel. They bounce off and they come out in parallel. That's one of the cool things about a parabola, is it focuses all the light. And that's how I remember where the focus goes, is it's where the light bulb would be, is if this were a headlight. Now, there's also a line on the other side that's new to you. It's called the directrix. It's this, in this case, a vertical line. You see the spelling right here, directrix. And the directrix is the same distance away as the focus is from the vertex. So if this is 1, then this would be 1. If this were 2, this would be 2. And we're gonna define that distance away as being the letter A. So we're going to use the lowercase a. So this would be negative a, I guess you would say. All right, and so I think that's all the vocabulary on that one. When it is up and down here, oh, I remember one more thing. We have this right here is called the major axis, and in this one, it looks like it's basically the x-axis. It's called the major axis. Over here, the middle of the graph right here, this is the major axis here. This one is facing up. So notice the vertex is right here. And then we've got the focus above it, which means the lens to that headlight would be facing up, right? Notice that the directrix this time is a line that is horizontal. So this looks like it's at y equals negative 2. All right, the axis of symmetry in this example is at x equals 1. Now, what are these other lines here? What on earth are these doing here? This is one of the interesting things about parabolas, is if you connect a line segment from the focus to the parabola and measure that, it will be the exact same distance as this line segment that goes directly at a 90-degree to the directrix. So that distance is the same. This distance is the same. And this little one here, this distance here is the same as that. So you could actually construct a parabola, I believe, with a compass and a straight edge, just using that, that information. All right, but of course, this has to be at the right place. It has to be at a place called the focus. Okay, so we've got a lot of vocabulary out of the way. So equations of parabolas opening along the x-axis. Let's write this down. That's left and right. And then I like my students to draw this in their notes. So left or right means that the parabola is going to look like this or this. Okay, you don't have to put all the arrows, but that's what it looks like. All right, notice the y squared. The y is being squared in this example, and the major axis, in this case, when it's left or right, is the x-axis. The x-axis. Now, when the x is being squared, this is an up-down situation. So this would be the y-axis, would be the major axis, and this thing is going to look like this. You're going to have your parabolas that look like that. Okay, so you got to keep those two straight. I'm going to be asking you, hey, is this a y squared or an x squared? Okay, so is it left or right? So if it's y squared, it's going to be left or right. Okay? If it's x squared, it's up or down. We have one more vocabulary word on here, and it's a wild and crazy one. I don't know who named this thing. But if you have the focus, all right, and you go parallel to the directrix, straight across, this line segment is called the lattice rectum. And the reason this is useful is because we're going to be able to go 2a in either direction and get those points. They're really easy points to get, which help you figure out how wide the parabola is. So once you know A, you can then draw the lattice rectum points, this point here and this point here, and endpoints on this line segment. Okay, so that's that term also. Okay, so find the equation of a parabola with a vertex at the origin. So the vertex is going to be at 0, 0. And it has a focus at 9, 0. So let's just sketch that real quickly. Here's the vertex, and here's the focus. Now, first thing I'm going to ask you is which way does this open? We have enough information to figure out which way it opens. Remember, the focus is where the light bulb goes. So if this is the light bulb, then that would mean the lens would be like this. So this thing opens to the right. Now that's a y squared. Remember in our notes up above? When it opens to the left or right, it's a y squared equation. So I'm going to write that down here. I'm going to write down 4ax equals y squared. The number 4 is just part of the formula. A lot of students ask me that. Okay, well, if this is at 9, remember in this problem, it said the focus was at 9, 0, right here, 9, 0. That's at 9, so that means A is 9. So I'm going to put a 9 in this, and I get 36x is y squared. There, we just wrote the equation of that parabola. That wasn't so bad. Once you know A, you can just write the equation as long as you know which way it's facing. Let's try this next one. Find the equation of the parabola that has the vertex at the origin and goes through 0, -5. So here's -5. That's the focus. Doesn't go through that. The focus is there. All right, so which way does this open? This opens down this time because, again, that light bulb would be on the inside of the lens. All right, so that's an x squared situation. And in fact, A is negative this time because it faces down. A is -5. So we go over here, we write 4a y equals x squared. And we put our -5 in there. And we have our answer, -20 y equals x squared. You see that wasn't so bad. That's the equation of that parabola. This is very different than earlier in the year when we used like opposite b over 2a and all kinds of stuff to graph these. We're not doing it that way this time. We're using some of these conic section rules. I did forget to tell you at the beginning, let me do that now, is where on earth did this, why is this in a thing called a conic section? Well, if you imagine drawing a cone, and then you slice it diagonally, what do you get? What is this cross section? It is going to be a parabola. It's going to be like this. If you were to look at that, this shape right here would be a parabola. So that's how we could create a parabola from a cone, is we slice it diagonally. So it's kind of cool. That's why a parabola belongs in a conic section. Graph the parabola. Well, 16x equals y squared. All right, so this is a y squared equation. Which ways do those go? Do they go up, down, left, or right? They go left or right. Now, what sign is A? Since A is positive, we can rule out the fact that it's not going to left, it's going to the right. Okay, so when we graph this, it's going to go to the right. Now, we need to solve for A. Here's how we do this, is we take the 16 and we just set it equal to 4a. So therefore, A is 4. Okay, so our vertex here is at 0, 0. That's going to change here in a moment, don't worry. Our vertex is at 0, 0. And the focus is to the right, 4. So here's the focus, because A was 4. Now this is where that lattice rectum comes into play, because I don't know, do I draw it like this or do I draw it like this? What does this parabola look like? Well, remember, A is 4. A equals 4. So what would 2a be? 2a is 8. So I'm going to go up 8. There's 4. there's 8. And I put a dot there, and then I go down 4. So 2a equals 8 over here. I'm going to go all the way down here. And I can now see how wide my parabola would be if the focus is at 4, 0. When you move that focus around, it changes how wide the parabola is. All right, so that's where that lattice rectum line segment comes into play. Horrible term, I know. All right, let's try this one. You might want to pause the video and give it a try on your own. See if you can figure out where that focus is. We know the vertex is at 0, 0. Okay, so let's solve for A. I guess before we do that, which way does this open? It's an up-down situation because it's an x squared, but we know it faces down, right? We know it faces down because A is negative. So we set 4a equal to -8. So A equals -2. So we go down to put a dot, that's our focus. And then, remember, we have to calculate what 2 of those is. 2 of those would be -4. So I go over 4 in either direction from the focus. Real simple. Just 2a, and that tells me how wide the parabola goes. I'm not worried about you getting any more points than that. That gives you an indication of how wide the parabola is. All right, let's move the vertex around. Just like we did with the circle conic section, we can have a center at HK, and we used HK earlier in the year. If you remember that vertex form of a parabola, we used H and K, so this is very similar. Notice that we might have the y squared or we might have the x squared, so let's get that back into our notes. The y squared is the left or right situation. The x squared is the up or down situation. Now, how does all this change? Well, remember, the vertex here is at HK. So this is over H. Well, this is A right here from the previous notes. So doesn't it make sense that we would just go H plus A is where the focus would be? This would be the focus right here. And then we can use that lattice rectum. Now, the directrix, this is a typo on my notes here, this would be at H minus A. Because you go, remember, you go -A to get the directrix in there. Okay, and then the same thing is if it's up or down there. All right, but instead of the A getting added to the H, it gets added to the K, because this is A right here, and this is K plus A. So if we used to go to K, K plus A. All right, that makes sense, right? Hopefully. All right, so we're going to graph these. It really isn't so bad once you get the hang of this. We have to harvest out our H and K. Now remember, H is always attached to the X in the formula. I meant to show that up here. You see how the H is always with the X. The H is always with the X, and the K is always with the Y. So H is always with the X, K is always with the Y. Now when you harvest out those numbers, the H goes first, the K goes second, and you have to change the signs when you grab those numbers out. So the vertex is at -2, 2. That's the vertex. Now does this open up, down, left, or right? Well, this is a y squared equation. Those are our left-right equations. And since A is positive, right, 4a equals 4, so A equals 1. Since A is positive, we go to the right. That's where our focus is, and we could draw our parabola. However, I really want to use that lattice rectum to get a couple more dots. So you see how I went 2a, this was 1a, 2a, up or down. That gives me how wide this graph would be. So there we are, that's how wide it would be. All right, so we did a decent graph there, and then the directrix, by the way, would be back here. This would be at x equals -3. This is called the directrix. The directrix. Okay, We've just got a few more problems to do here. This is an x squared equation, so this is going to be an up or down situation. But of course, it's going to be down because a is negative. So that's kind of handy to figure that out, right? The vertex is going to be at h, k. But again, you have to change the numbers when you harvest those out. So -4, -7 is way the heck down here. That's our vertex. We already said this thing is going to open down. Let's figure out where the focus is. -8 equals 4a. So a equals -2. So I start at the vertex and I just count down 2. There's my focus. And then I go 2a in either direction. Remember, a was -2, so I went over 4 in either direction. And there's my parabola. And then the directrix would be up here. This would be the directrix. And that's at y equals -5. Y equals -5. All right, very good. All right, one more question to do here. Find the equation of the parabola with vertex 3, -4. 3, -4. So here's my vertex. All right. And the focus is at 0, -4. Aha. So which way does this open? If that's the focus, the headlight lens must be like this, right? Now, are those x squared or are those y squared equations? Those are y squared. So let's write it down. 4a times the quantity x minus h equals y minus k, the quantity squared. That's our starting point. Now, our vertex was at 3, -4. That's your h and your k. So we put that in. That would be x minus 3 equals y plus 4. Remember, you have to change the sign. Now, what about a? How much is a here? Well, we just zoom in and we count. Look here. This is a equals 3. A equals 3 right there. So we put a 3 in there and we get 12. We're done. It asked us to write the equation of the parabola, and we did it. All right, so today you learned about the conic sections, the different forms of parabolas. Those on the second page here, the vertex was not at the origin. We moved it around. We moved it to HK, but the idea was still the same. And on this front page here, we learned about how to do that when the vertex was at 0. It was really easy. Once you figure out A, you're pretty well home free. Okay, hopefully this was helpful, and good luck on your homework, and until next time.